Hello and welcome back. In this video we'll continue to look at solving quadratic equations. At the very end of the last video we talked about how sometimes there can be two solutions to a quadratic equation, one solution, or no solutions, meaning that there are two imaginary solutions but there are no real solutions, so no real number solutions. So I quickly want to look at this equation here, and I'll solve this by factoring first, and then we'll come back and look at the quadratic formula. So here again, what we really want to do when we're factoring is to break this apart into two monomials where we only have an x in both of them. So again, if we multiply the first two terms, the x times the x gives the x squared, which is perfect. And then the next two things I need to multiply together to get 25, and when you add them up you should get 10. Well, that's fairly straightforward. There's only two combinations of numbers that multiply together to get 25, 1 and 25, which doesn't add up to 10, or just 5 and 5. So again, we factored this left-hand side. If you were to multiply all this out and simplify, you'd get x squared plus 10x plus 25. And then here we can see that we have two numbers that multiply together to get 0. So either x plus 5 is equal to 0 or x plus 5 is equal to 0. Well, that's the same thing in both ways. So this is x is equal to negative 5 or x is equal to negative 5. So there's only one solution. X is equal to negative 5. If we were to come back and look at the discriminant, we should be belonging to the second case here. So let's check this out. A is going to be 1, B is going to be 10, and C is going to be 25. So if I take b squared minus 4ac, b squared, so 10 times 10 is 100, minus 4 times a times c, 4 times 25, well that's 100. So we get 0. So we are indeed in this case. The discriminant is 0, which means that there is only one solution. Cool. The last sort of technique for solving quadratic equations comes from the following. What we noticed in this last one is that, it was really easy to see that, okay, so there's something times something is 25, and when you add them together you get the 10, but it happened to be the same thing in both places. And it will always look like this. If we have x plus b times x plus b, well, if I FOIL this out, I'm going to get a b squared back here, and I'll get an x times a b and an x times a b. Well, that adds up to 2bx and an x squared. So when I have this, this is going to be a perfect square, and I can also write this as x plus b quantity squared is equal to 0. So this right here is fairly nice. And not every quadratic equation is going to sort of look like this, but we can sort of complete this square. So this is called completing the square. So we can add something to both sides to get it to look a lot like this, and then we can use this fact to solve the equation. So the way this works, so we'll go through an example in a second, but the sort of method here. Typically we'd have an ax squared plus bx plus c, but I'll just assume that this first number out here is just a 1 for the moment, and then let's look at how we complete the square. There's just a few steps. What we want to do is we want to get this to look like something squared. So we're going to use the formula that we saw up above. So first what we're going to do is we're going to move the c to the other side. So step 1, x squared plus bx is going to be equal to negative c. Just moving that to the other side. to make this look like a square, this is the trick. This is the important step here. We're going to add b over 2 squared to both sides. So b over 2 squared, negative c, and then b over 2 squared. So far, I've only added a little bit to both sides, but this makes this side over here factorable. And this turns into x plus b over 2 quantity squared. So again, if you were to FOIL this out, you would get b over 2 squared, and then x times b over 2 plus x times b over 2. That adds up to bx. So then we get the other side. And then we can take square roots and solve. But we do have to remember to take plus or minus here. So if I take the square root of both sides, I'm going to get x plus b over 2. It's going to be equal to the square root of all of this. And then we'll have the positive root and the negative root. This is something that in the question, this will be a little bit simpler to solve. So let's go through an example of how this actually works. So let's complete the square here. So to complete the square, we do need it to look like the quadratic polynomial. So let's do this. So we've got, let's FOIL this out. So x times x. So the first terms, the outer terms, x times 5. The inner terms, negative 1 times x. And the last terms, negative 5. And all that's equal to 2. So we will consolidate everything. So we've got x squared. We've got so 5x minus x is going to be 4x. And I want to get all of the constant terms to the right-hand side. So that's what this first line is saying up here. So I'm going to move the minus 5 to the other side. So by adding 5 to both sides, I'll get 7. Cool. Now I can complete the square. So the trick, add b over 2 quantity squared to both sides. So b here is 4. So what I'm going to do is take 4 divided by 2, and I'm going to square it. 4 divided by 2 is 2. 2 squared happens to be equal to 4. So in this case, this is quite simple. So we get x squared plus 4x, and then I want to add 4 to both sides. Plus 4, plus 4. And the reason that I do all of this is because the left-hand side is now a perfect square. So if I simplify this, this is going to be x plus 2 quantity squared. Why 2? Because it's half of b. And again, we can FOIL this out. 2 times 2 is 4. 2 plus 2 is 4. Everything works. So that's going to be equal to 11. And now I can take square roots of both sides. And this is going to be x plus 2 will be equal to plus or minus 11. Sorry, the square root of 11 after we take the square root of both sides. If I move this negative 2 to the other side, we'll get x is equal to negative 2, either plus the square root of 11 or minus the square root of 11. So we have two solutions. X will be equal to negative 2 plus the square root of 11, or x is going to be equal to negative 2 minus the square root of 11. So we have both of those as solutions here. So completing the square is maybe a little bit tedious, and factoring is generally easier. I almost like using the quadratic equation for something like that as well. But it's good to keep this in mind. This will be a trick that we'll use later in the semester as well. So understanding it now will be helpful. And I'll finish up the lesson in the last video.